The space looks like a vast empty ocean sprinkled with rare islands of galaxies. Subscribe and like for more about the cosmos. In the 1950s, astronomers noticed mysterious loud radio waves coming from spots all over the sky. They were named quasi-stellar radio sources or quasars because they were dots like stars but were seen in radio waves rather than visible light. Everything about them was strange. Some flickered, others emitted radio waves, but all seemed to be tiny. They all moved extremely fast, as much as over 30% the speed of light. The only explanation was that they must have been so that their apparent speed was actually the expansion of the universe moving them away from us. But these enormous distances meant that quasars couldn't just be stars, but the active cores of galaxies billions of light-years away. And it gets crazier. To appear so bright and loud, given these vast distances, they are thousands of times brighter than the entire Milky Way. Monsters exploding and screaming into the void with a violence not thought possible before. As we mapped the sky, we discovered over 1 million quasars. And they all seem to be very far away. Looking into space far away means very long ago, because light takes so long to reach us. Quasars were common in the early universe, having peaked in number 10 billion years ago, when galaxies, and the universe itself, were still very young. Let's go back in time just 3 billion years after the Big Bang, and see what was going on back then. The incredible power of quasars. How could an early baby galaxy be so incredibly bright and violent? All that light and radiation couldn't be stars, as there weren't nearly enough of them. And since galaxies tend to grow with time by merging, the starlight from small galaxies shouldn't be far brighter than any galaxy today. There's only one way to generate the vast amounts of energy a quasar shines with: feeding supermassive black holes. We still don't know how exactly they formed, but it seems that every galaxy has one in their center. But how can the brightest things in the universe be black holes, which trap anything and everything that crosses their event horizon? Well, the light of a quasar is not coming from inside these black holes. Rather, it comes from the space around them, a massive orbiting disk of gas called an accretion disk. Quasars use the same fuel as stars: matter. It's just that black holes are the most efficient engines for converting matter into energy in the universe. The energy released by matter falling into a black hole can be 60 times greater than that released by nuclear fusion in the core of a star, because the energy released by a black hole comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up to almost the speed of light before it crosses the event horizon, buzzing with an incredible amount of kinetic energy. Of course, once inside the black hole, it takes that energy with it. You only get to witness this energy if you drop your matter in the right way, fall straight down, and the outside universe gets nothing. But when you have a lot of matter, it spirals in incredibly fast towards the event horizon, forming a disk. Collisions between particles and friction heat it up to hundreds of thousands of degrees. In a space not much bigger than our solar system, the core of a galaxy can release many times more energy than all its stars combined. This is what a quasar is: a supermassive black hole having a feast. And these black holes eat a lot. Typical quasars consume 1 to 100 Earth masses of gas per minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out, meaning the filaments of gas around quasars could feed them a balance. But now, the universe is a banquet, making them vomit insane amounts of light and radiation. The brightest quasars power jets, tangling the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they launch enormous beams of matter out, plowing through the circumgalactic medium, forming plumes of matter that grow to hundreds of thousands of light-years in size. It's almost unfathomable in scale. A tiny spot in a galaxy, carving out patches of the universe, hundreds of thousands of light-years long. But quasars can't eat for long, maybe a few million years, because their feast ultimately kills their galaxy.